Okay, so you are welcome to this tutorial once more, though after a long time. Yeah, so today we are going to look at a 2024 Mathematics GCE Paper 2. And I'll specifically go on the part of question 5B, which is derived from the topic called computers. Let's get started. So we have this question B, question 5B. Question 5B says, the flow chart below shows the steps that are carried out in calculating and displaying the area A of a sector, given its radius r and angle of the sector theta. Okay, so I'm going to draw a flowchart here. Then the question is saying write the pseudocode corresponding to the flowchart program above. So here is the flowchart. Okay, we start. And after that, we enter r and theta. Okay, that is the symbol used for entering. Just pray there to be clear enough. Then from there, we have this. Is r less than 0? Okay. Is r less than 0? Okay. This is a question. Okay. Then always, on the decision symbol, there are always two options that you have to check out there. There can always be the possible part where we say yes. If yes, what happens? They are saying print error, error is not valid. So you write, okay, print error, okay, error is not valid. Okay, so we have that there. Okay, and after that, there is also the part for no. Is r less than 0? And then they are saying no. Then here, what happens if you say no? We have a formula here to write. Area equals, open parenthesis, theta over 360 times pi times r. Then this is r, that is the symbol for squared, r squared. And this one will be enclosed in a symbol for process. This is the symbol for process. It looks like, I would say, it looks like a rectangle. Okay, then from there, of course, we have to print A, okay, then the symbol for printing goes like that, and then after that, we'll say stop. Okay, then there we also have something which comes there. Okay. Now, after having this diagram, which is a flow chart, after having this flow chart, now how do you go about answering now the question which says Write a pseudocode corresponding to the flowchart program above. So all what is being illustrated or rather emphasized here is the fact that they want you to now convert this whole information, because practically a flowchart and a pseudocode, they are two sides of a coin. All these are called programs. But then a pseudocode, it's a program which is written in statements using English words. But then a flowchart, it's also a program, but it is written using symbols. Okay? Enter symbols, process symbols, connectors, and many other stuff which are usually never indicated here. But then that is how a flowchart is. A flowchart is usually written. Now, since you have this, remember we are looking at the 2024 GCE past paper 2. That is question 5B. Now, how do we go about answering this? It's very simple when you want to illustrate it using pseudocode. The best way to go about this is just to be following what you have been given here. But the only key part is on the decision symbol. What is it that you need to do? See? What is it that you have to do? That is what matters the most. So you're also able to see down here. Okay. So this is what we're going to do. Write the pseudocode. I'm going to write here to say pseudocode. Okay. Hope this part will be clear. It's a little bit bright with the window here. So we have to start program. So you start. Then you enter R and theta. That is exactly what you have to write here. So you enter R, also theta. Now, when we reach this part on a decision symbol where there are always two options of either saying yes or no. The only thing that you have to do here is to convert this question which was asked to say, is R less than 0? On the pseudocode, it should be an if function. So this is what you do. Say, if R is less than 0. You see that? If R is less than 0, now what comes mostly, not mostly, always, after the if function, what comes after the if function here should always be the part where there is your a yes part. If R is less than 0, then what should follow next there on your pseudocode is the part for the yes part. After the if function, the next part which should follow, I emphasize there, it should be the part where there's your yes. Okay, so you say start, enter R and theta. If R is less than 0, then print error, the yes part now. Say print error R is not valid. Okay, R is not valid. That is what we're writing there. Now, after that, I always give an example of somebody making a decision of whether to go to the market to buy a veg to eat. And if they do so, they'll be able to cook and eat. But if they don't, again, they'll still stay hungry. So this is an option where you can either decide to do something or not. There are two things there which are involved. Very, very important. Very, very important. So here you can either say yes or no, but after the if function, then what should follow should be yes, but else means if not. So you say else, okay? Else, that is now when you come on the part where there's your no part. Okay? That is now when you come on the part where there is your no part. Else, bring this part now, area equals, open brackets, or rather parenthesis. Okay? You say theta over 360 times pi, okay, times r, then to the power 2. You close it that way. Then what follows now? After that, you print A. Just copying the stuff which are here. But what matters the most, I emphasize, it's on the decision symbol, because on the decision symbol on the flowchart, it says is R less than 0. But on the other hand, on the pseudocode, it should be an if function. It should be an if function. Then you print error message on the yes part. Else, you go on the part where it says no. You write the formula that you have been provided with, though it's not always a formula, but whatever that you have been provided with on the part where it says no, that is what you write after the else part. Then after that, you print whatever that you have to print there. In this case, we are printing area, which is our A. You say print A. After you print A, definitely you have to stop. Okay, definitely you have to stop. And this marks the end of our pseudocode program. So you start, you enter R and theta. Then if R is less than 0, okay, then you get what is on the yes part. You say print error message, or rather print error, R is not valid. Else, A which is the area, and that is the part for on the no part on the what, on the flowchart, sorry. And then after that, you say print A. Then finally, you end the process. Okay, so I'm going to get again another question. Now, a question which has got the the pseudocode. Then we need to convert it back what to the pseudocode. Here it looks a little bit shiny. You're able to see here that program there. Okay, so I'm going to give you the question for the year 2023. Okay. Okay, great. So not forgetting also that a pseudocode and also a flowchart are two sides of a coin. Those are both code programs. Okay, so here's the question. This is 2023 paper 2 GCE. This is question 5A. Okay, 5. 5A. Okay, and what we have here, this is what we have. I'll read the question. The program below is given in the form of a pseudocode. The program below is given in the form of a pseudocode. All right, and here is the question. Here is the pseudocode, I mean. Okay, saying begin. After begin, enter n. If n is less than 0, then, okay, then display error n must be positive. Okay, then after that we have now the else part. Else sum equals n over 2 times 2 times a plus, open bracket, n minus 1 close times d, then you close. Okay, sure this formula sounds so familiar. This is the formula for GP, calculating the sum of for AP, arithmetic progression. Okay, then from there we say, and if display sum, and we say n. So the question is saying, draw a corresponding flowchart for the information given above. Draw the corresponding flowchart for the information given above. So you are able to clearly see that, in fact, what is going on here is the fact that the first question that we were given here was talking about a flowchart making a pseudocode which was corresponding to the flowchart that we were given. But in this case, we have been given the flowchart, the pseudocode itself. Okay? And what we need from here now is the fact that we need to convert this information onto what we call the flowchart now. Onto what we call the flowchart. Okay, and this is what we are going to do. I use this part though it sounds to be so brighter. But I'll try to use this very part. Good. This makes some sense. That part. Let's draw it closer. Okay, so this is what is going to happen. Getting the information which we have here, putting into the flowchart. Of course, knowing to say the symbol for begin or the symbol for start should always be this symbol. And you say, you're just writing what you have here. If you have begin here, you don't need to write start. Okay? If you have end here, you don't need to write it, stop. So here we have begin. You have that. Then after that, what next? Enter n. And you know the symbol for entering. The symbol for entering in this case goes like that. enter n. After entering n, then now is the part that I was emphasizing on the previous question to say. When you have this part for the if function on the flowchart, the if function will be represented in the form of a question. And this question will be, is n less than 0? Okay, so we'll have this. Then we'll say, is n less than 0? And you put a question like that. Then after that, we always have two options on the decision symbol. That is the yes part and the no part. Okay. If no, if yes, if yes, what should follow next is to display the part which comes immediately after the if function is the part for yes. I always I mentioned that area. So on the yes part, we say display error any must be positive. So write this, display error, okay, display error any must be positive. So I don't have enough space this side, but you already know the symbol which must be used. It's more like a rectangle with slanted sides. So we are using a rectangle here to display, more like what we used there, but with a little bit slanted sides. That is the symbol which is used for when displaying the given function, so to say, or rather statements. Okay, then from there, we are here.
No problem.
Okay. Then from there, we have now the part for no. This is the part for no. Is any less than 0? No. If no, then what? That is very important. If no, that is the part where it says else on the pseudocode. Else sum is equal to, so we need to write this whole stuff that we have been given here. Okay, and this is the way it will be. Okay, sum equals, you really need to copy these things exactly the way they have been provided on the pseudocode, putting them on the flowchart. Exactly, no difference. Where they have put some quotations, you also indicate them on the flowchart there. Okay, sum equals n over 2, okay, times, open bracket, 2 times n plus, open bracket, n minus 1, close, times d, then you close. Then this whole thing must be enclosed. This whole thing must be enclosed in this symbol for process, which is a rectangle shape. If you take a close look at these symbols, for a process, it's different because this is a rectangle with straight lines in the sides. But for the enter symbol, or rather the input symbol has got the what? Has got the slanted sides in terms of the lines which are there. So pay attention on the shapes, very important. So we have that. Then the pseudocode keeps on saying, or rather continues by saying, else sum is equal to that, and if. Now this part, they are just telling you that you can stop the program only if the sum is displayed. And when you say the sum, of course, we are talking about the computations of this whole answer which should be provided here. It's more like you're saying 1 plus 1 is 2. And that 2, it is the summation of 1 plus 1. So when we say this display sum, we mean the answer which has been computed here to be displayed down here. And that is exactly what we have to do. So we are going to say, and what is the symbol for display? The symbol for display is the same as the symbol for enter. If I have to use other terms, I would say the input symbol is the same as the output symbol. Okay? You understand this. Then the begin symbol, or rather the start symbol, is the same as the end symbol. Okay, so here we're going to say display. What are you displaying? Display sum. Okay, then this will be the symbol, slanted one on the side. Okay, then after that, what comes next? When the sum is displayed, of course, the program will also, at the end of the day, need to end. When you begin, you have to end. When you start, you have to stop. Okay, so here we say end. Not forgetting that this must also move together with this so that it also comes under and end there. Okay. So this was what I prepared for you today, and thank you so much.